Hello, I'm going to show you today how to make a follower graph from Bluesky. It's a little rough right now. If this video gets any attention or people are interested, then I can polish things up a little. So let me just jump to my code. One of the rough parts is that for the life of me, I try to get Python and R to both run together in Quarto, and I just struggled to get it to recognize my virtual environment. Anyway, so I have two separate files to show you. One is Python, one is R. So this is Python first. This is kind of my typical workflow, is to sort of get data, work with APIs using Python. I find it much easier, sort of clean things up, and then use R for visualization, especially for network visualization. So this is pretty rough, but hopefully it's helpful. You can build on it and do your own cool stuff. So Bluesky is really nice. They're great. Unlike most social media companies right now, they are very open. Their API is very generous. I found it really easy to do this, especially with a little bit of AI help. But there's an atproto, the AT or app protocol is sort of what Bluesky runs on, open source protocol. And there's a library, a Python library for it. So you have to run, pip install or conda install or whatever atproto, and then import the client. And then I just have a couple of simple functions here. One gets all the follows. So what we're going to do in this is get all of the people that I follow, and then for each of them, get all the people that they follow and create a network just between the ones that I follow, if that makes sense. So how are the people that I follow connected to each other in a follower graph? And so this will get all of my follows, the people that I follow, and then we'll also get all the people that they follow. So we start with a quick empty dictionary. There's a cursor, which tells you the next. So when the network object is returned, it has a cursor, which you need in order to get the next page of results. So if we want to get all of the people that I follow or that someone follows, you'll need to page through them. And so what this does is we get the response for a given handle. We can get a maximum of 100 at a time, so we set that to the maximum, and then we save or we use the cursor that we have. So we start with none as the cursor, and then we'll get the first page, and then we'll add the followers that we get, the follows that we get. This list of follows is what's going to get returned. We'll add it to our list of follows. And then if we don't get a cursor, in other words, we're on the last page, then we break. Otherwise, we'll set the next cursor to the cursor that we get, and we'll go to the next page. So that's that first function. The second function takes all of these. So I'll show you what they look like in a bit. So let's come back to that. So the main function takes in a username, logs in to the, creates a client, logs in, and then gets all the accounts that the user, so this username, gets all the accounts that they follow. And then it creates this empty dictionary, and for each user that is followed, it gets all of their follows, and creates a dictionary from the current user that we're looking at to each of the people that they follow. So to a set of them. So for each person, we have the key is the username, and the value is a set of the people that they follow. So that's what we do. We'll include a sleep so that we can not be too mean to the Bluesky servers. And then we make the graph. So here's what happens here. So for each user and the set of people that they follow, for each person that they follow, we see if they're in the following dictionary. So in other words, were they part of that original set of people that I follow? If they're not, we're just going to get rid of them. So if they are in the following dictionary, then we will append a tuple of the user and who they follow. So this is going to be our directed graph an edge from each user to the people that they follow, who are also followed by me. So only those people. So that's the idea. And then we just write that out to graph, call it following graph.csv. You could use the CSV library if you want. I just wrote this in plain text. It looked like it worked okay. I usually use the CSV library, but I didn't. So there we go. So we're writing out the user and the following. We'll start with a header that's just from and to. And then here's my account, so that's what I used for it. Okay, so that's the idea. Now let's jump over to the R code. So here is the R code, this nice markdown document, Quarto document. So we'll load the graph. This just loads the libraries we need, and then it loads that CSV file that I just created, and then creates a graph from it. So this is an iGraph object, and then we actually make it a Tibble graph. So which is the tidy graph version of graphs. So that's going to be G, and then I wanted to get a sense of kind of who the main people were. So I'll back up just a little bit. I expected to see some nice groups. Often when we look at networks like this, I thought I would see like, here's my academic people and here's my political people, and et cetera, et cetera. I'll show you the results in just a second. But so I thought it would be helpful to pull out the kind of the top people that I follow, ideally in each group. I didn't go that far, but kind of show kind of some representative people from each group. So that's what this top part is doing. Excuse me. We'll take G, identify the nodes with the highest between centrality. Excuse me, and just make a list of them. So this pulls the names of the top 5. You can, if you want this, change that to 10 or whatever. The higher it is, the more likely it is that they're going to overlap with each other, and you'll get R complaining to you. But it's pretty smart. So you can, I think if you're above about 10 or so, you might be in trouble. And then we'll plot the graph. So this takes G, adds labels. So I used label propagation method for getting groups. Adds groups. So this is label propagation to identify groups. I save that as a variable group. And then later down here, right, we color the nodes by group, add edges, and add labels. So this code here takes our nodes to label list and filters the graph to only those which have a node in the nodes to label list, and adds a label for those. Give it a title, give it some nice colors. And so if you look at mine, these are the folks with the highest between a centrality, but it is just one giant blob. So I used the default layout. I looked at one or two others. It didn't really matter. It really is a blob. And I mean, maybe that says something about my network and my interests, like what I use Bluesky for, I guess. It maybe says something about academics, that we're maybe more homogenous than we think. I mean, these are most of the people I follow are social scientists, or social scientist adjacent. But there's a lot of homophily on Bluesky. I think that is true. I don't know that this is great evidence of that, but at least that my network was more homophilous, more part of one group than I thought it would be. So hopefully that's helpful. Play around with it. I will put the code, I'll put links to these HTML pages. I think I can also link to I don't remember how I uploaded it, but I think I can link to the source code as well, but you can copy and paste it anyway. So hopefully that's helpful. Again, if there's interest in this, let me know, and I can kind of clean it up, write some more nice documentation, etc. But it should at least get you started.